discussing over the distance. Okay, so some point in the time of robotics, we came to the point that we require to measure distance between our robot and and another object or a thing. Okay. So today we are doing something like that. Hello. Okay. I have a phone. That's why my voice is not that coming that much. Okay. Hello. Okay. So today how we can measure distance between our robot and that object. Okay. So you know distance is okay. Okay. So you know distance is equals to speed into time. Okay. So we are using this classic formula to measure our distance. Okay. Okay. So we can hear your background voice. Okay. Okay. Let me change my place. Give me a second. If that is helpful for you. So we know that the distance equals to speed into time. Okay. So yeah. Okay. Okay. So speed is equal distance into sorry distance equals to speed into time. Okay. So we are using a sensor called ultrasonic sensor. Stand for ultrasonic sensor. Okay. So what does ultrasonic sensor do? It has a let's jump right into our Tinkercad circuit. Okay, I will show you there. Okay, let's jump into a Tinkercad circuit. Okay. So wait for 5 minutes, guys. I will change my place. Okay? So just wait for 5 minutes. So let's begin. So let's begin a new. Sorry. Let me restart. Yes. Okay. We'll go to the circuits. We'll create a new design. Okay, and I will show you how to use the ultrasonic sensor. Okay, so this is your first sensor in our robotic class. Okay. Okay, okay, so you just scroll down. Okay, okay, so this is ultrasonic sensor. So go to all. Okay, so this ultrasonic sensor. Mhm. Okay, so here is it. 4-pin ultrasonic sensor. Okay, let me zoom in. Okay. So this is an ultrasonic sensor. Okay, this is called a trigger pin. This is called an eco pin. Okay, so what does this trigger pin do? It send a sound wave. Okay, when it send a sound wave, it send a sound wave, and then the sound wave get reflected back. Okay, this echo pin, or we call it a receiver, receives that echo pin. Okay, so that sound wave. Okay, so what happens that it send a sound wave and it receives a sound wave. Okay, in this time, so the time it calculates the time. calculate the time till when the signal is sent from the transmitter and it receives from the transmitter. Okay, so we will get from we will get one thing that is sorry, that is we get the time. Okay, and we know what is the speed of sound. Okay, so we know what is the speed of ultrasonic waves. Okay, find out the speed of ultrasonic wave. Okay, note it down. Okay. Okay, so it is somewhere 340 meter per second. Okay, so I checked this 340 meter per second. So you need to remember that. Okay, so here we have the speed. Okay, and we will get us and we will get this time from this. So we know that the speed is equals to, sorry, distance equals to speed into time. Okay, that's short simple it is. Okay. Hello. I think my voice is somewhere clear. Okay. So we will going to do that. Okay. The first thing we need to do is first we need to find out how to find out the sound. Okay. So sorry, how to find out the time. The first program we are making is to find out the sound, and that we are printing on our screen. One second. Good morning. Okay, give me a second. I think my voice is distance to time. Okay. Okay. Thank you. Thank you. Okay. Okay, so now we have that. Okay. So we'll take our Arduino. I think it is somewhere here. Make it basic. That's basic. And we have this Arduino. Okay. Yes. Gap. Make it industrial. Okay, let me connect this and we'll find the sound that is traveling back. Okay, so first we calculate the time of sending the sound and receiving the sound, and then after that we will calculate the speed of the sound. Okay, and in the same way we will calculate distance from the speaker. Okay, so that what I'm doing is I am connecting this trigger pin. Okay, so we need this trigger pin, and I'm connecting it with. Okay, okay, so we have this. That's fine. Okay, I'm connecting from pin number 12 this pin, okay, and I'm making this trigger pin, okay. Let me put some color, okay. So this is a triggering pin, okay, and let's change it to, okay. So receiving pin yellow color, okay. And I need to give the VCC and the ground, okay. So we have this 5 volt, okay. I'm taking the 5 volt from here. We know how to take this wire. I'm making this red, okay. And we have a ground here only, so we don't waste the wire, okay. Wasting a wire is also not a good thing. Okay, so we are connected, and this is a flag. So we are ready. Our hardware is ready, and now it's time to code. Okay. So we will take text mode. Continue the text mode. Okay. So as we know that we are using that variables, okay, in the place of constants. So first we define variables for these pins. Okay, so I write int. Okay, int for the integer, as we know that pins are an integer number, so we'll say trigger and we'll say pin. Okay, so trigger pin equals to 12. Okay, so see from, okay, so you can see from here, right? Okay. So as you can see from here, okay, so we have this trigger pin connected to pin number 12. Okay, so I have given this, okay, in the same way. And okay, now from here we have echo pin. We say echo pin. Okay, so it's called a receiving pin, and we have this 11. Okay, so we are connected with 11. So we write 11. You can see that it is a echo is connected to pin number 11. Okay, so we are set. Okay, after that we need a variable for time. Okay, so we say the time variable, which is equals to this ping time. Okay, so the ping time variables. Okay, okay, then we have okay, so I'm not defining that what is this number. Okay, we will calculate it. So okay, we have selected now the setup mode. Just I copy this because we need it 3 times. Okay, so first time, second time, okay, and third time. Now we'll change it. Sorry, no third time because we are using only 2 pins, so we need only 2 times. Remember that we are using pin number 12 and 11. So we write 12, and here we will write 11. As you know, both are okay. So one is input. Okay, so you can remember that we are tracking back the sound. Okay, this is not output, this is an input. We need to define that this is input. Okay, so I define that input. Okay, so what you can do, you can simulate it now. Okay, so why you can simulate it now? So if you have an error, you can recognize it. Okay, okay, so it doesn't have any error, and we have set up the one more right. Let me remove all this. So okay, so we need to first we need to send the trigger pin high. Okay, so how we can send? We are sending a trigger. Okay, sorry, digital right. Yeah, no need to remove all of them. Okay, we just need to remove these three. Okay, okay. So we need that digital right, and let's remove this statement. Okay, so we need to use the digital right, and we are digital writing our trigger pin. Okay, so we are writing our trigger pin. We say digital right trigger pin. So we have trigger pin, and we need to hide it. So first we need to low it. Okay, so that any unknown signal will not set from it. Okay, so we should low it. Okay, we load it, low it. Okay. Then we need to give a delay. Okay, so sending a sound and receiving it is very rapid fast. Okay, we cannot use the normal delay function. Okay, so we can not use the milliseconds. Okay, this time we need to use the microseconds. Okay, so what is micro? 10 to the power minus 6. Okay, it means that 1 by 10 to the power 6. Okay, so it means that 1 second has 10 to the power 6 milli microseconds. Okay, so we are using that microsecond delay. Okay, so the way of writing this delay, and the M is capital, micro, micro seconds, okay, and, and we need to give it a 10 micro. Okay, so what we are doing is we are just turning off that pin number 13 for 10 micro. Okay, and we need that again. Okay, so what I will do, I'll just copy this. Okay, I'll just paste it. Remember. Okay, so this time what we are doing is we are making it high. Okay, so first we are making it low, and then we are making we are sending a pulse. Okay, so proper pulse. Okay, so we are making it we are, okay, so then I can show you like that. Okay, we have notation. Okay, so okay, so you can understand like this. So this is a wave. Okay, if something is going on pin number 13, it will make it low. Okay, then we have a pulse for 10 millisecond high, and then it's go like that. Then we have pulse for second low, and it's go like that. It's something like that you see on your heart monitor. Okay, it's That's all. Okay. That's okay. Now, when we have done that, okay. So now we need to blow it again. We need to blow it again, so that receiver can understand that there is only not only a single pulse that's coming on. There are multiple pulses that are going and coming. Okay. Yeah, that's control C. Yeah, okay. I just remove that. Okay. So I'm making it completely down until that next instruction is performed. Okay. Now from here, okay, we need to find the time. Okay, so for the time we have make a variable. Okay, let's copy this variable. Okay, copy this and paste it here. And what we'll do is we will use a function. Okay, so we have a function here. Pulse in. Okay, so we write it as a pulse in, I capital, in small. Okay. So we have echo pin. Okay, echo pin. Okay, so we just define the echo pin there. Okay, and okay, we are reading it from here. Okay, we are not telling it to make it high. We are just reading it. Okay. So whatever that is how much time this pulse is on. Okay, so that travel time is stored in this variable. Okay. Okay, and we have a delay, and that is of 20 milliseconds. So that the wave comes back and it is calculated. So that's we require that time. Okay. After that we have serial dot begin. Sorry. Just remember that I just forgot to the serial dot begin because it's required. That serial dot begin. Serial. Okay. So printing, turning on our serial monitor. Okay. Serial dot begin. Okay. We are turning on our serial monitor to see the numbers which is we are giving it a broad rate. Okay, so we are giving at what speed this should it should be matched with the output speed. Okay, so here we are beginning it and here we are using it. Okay. So we say serial got print and LL means new line statement. Okay, and we are just operating our print time. Okay, so print time. So whatever the time we are getting it, we are printing it. Okay. 1 second. Yes. Okay. Good morning. Okay. Okay. So we got in the what is the name? Okay. Now time to run this code. Okay, and we will see that how much time it's taking. Okay. Let's see. Okay. So you can see there is just okay, let's click somewhere here. Okay, so here is somewhere is our object. Okay, so it's showing that it is 50 centimeter away. Okay, and if I just open my code, okay, and if I just okay, I just open my code and I just run on my serial monitor. Okay, so see, it is showing me the time. Okay, so it's in nanosecond. Okay, it's in nanosecond. Okay, okay, let's make it a little bit closer. Okay. Okay, so see, our time is reduced. Okay, so as you know that okay, the more is the distance, more is the time. Okay, so now I'm not reading that much. Okay, so you can see that when I come close to it, okay, so it has some okay, so it's okay when I take it far, okay, the value will be this. Okay, it's not increased suddenly, but it take time because we have used the delay. Okay, so one thing is clear that we are getting a time. Okay, we are getting a time. Okay, and we need to find out the distance. Okay, just stop simulating. So just clearing it off. Okay, so we have the time. Okay, okay, we have the speed also. Okay, so just first multiply both of them and we can find out the distance. Okay, that's not that easy. Okay, so what is the okay, what is the thing? Okay, so distance is equals to, we want distance in, okay, so what, how we want distance, we want a distance in centimeters. Okay, we want a distance in centimeter. Okay, we have a speed in, we have speed in 340, okay, 340 meter per second. Okay, and we have time in, okay, we have time in microseconds. Okay, okay, you know that we want this in centimeter and we have an uh, different units. Okay, so it is not possible to get this centimeter without changing these units. Okay, so what we will do, okay, note it down carefully. Okay, so we will change this meter per second. Okay, so we'll change this meter per second. Okay, meter per second speed into centimeter, okay, per microseconds. Okay, okay, so what happened that, so if we have that centimeter microsecond upon mc, okay, ms, sorry, okay, so we have microsecond, this is speed. Okay, then we have time, time is also in microsecond. Okay, I am taking only the units, okay, not anything else. We have the distance here. Okay, okay, so this microsecond cancel this microsecond and we have distance in centimeter. Okay, so we'll get a distance in centimeter. Okay, so how it convert this 340 meter per second into centimeter, the question is that. Okay, so let me clear all of the drawing and make your calculation again. Okay, so we have a distance. Okay, so we just say like this, distance. Okay, and then we have that 340, 340. Okay, so we have 340 and this is meter per second. Second. Okay, so we'll multiply it by, okay, so we need to convert this meter into centimeter. So we know that 1 meter, you know that 1 meter is equals to 100 centimeters. So we have the centimeter. Okay, and then upon we have 1 meter. Okay, okay, so what is this? Okay, we can write 1 meter upon 1 meter. That's okay for you? Okay, we can write like that. Okay, so 1 meter is 1 meter, that is same thing. Nothing is above, nothing below. Okay, that's when we cancel out them, you will get one. Okay, but we know that 1 meter is equals to 100 centimeter. Okay, so just convert that 100 centimeter for 1 meter. Okay, so this how we get this value. Okay, so this is how we get this value. Okay, remove this. Okay, so now what happened, this meter cancel this meter. Okay, then we have that 34000 centimeter per second. Okay, so our speed is now, okay, so now we need to cancel this second also. Okay, so we know that okay, so our, this is our new speed. Okay, remember this is the speed. Okay, so this is still, now we are in the speed. Okay, we are not calculating the distance. Okay, now we need to cancel this speed. Okay, for canceling this, sorry, for canceling this is second. Okay, this is second. Just remember that, put a word also. So we have a second. Okay, so we know that okay, note it down fast. Okay, so we have okay, I will make it here. So we know that 1 second upon 1 second is okay. Okay, and we also know that 1 second is equals to 10 to the power 10 to the power 6. Okay, so we have 10 to the power 6 microsecond. Okay, so you know what is 10 to the power? Well, if you are aware of the 10 to the power, 10 to the power 6 means 10 multiplied by 6, 10 multiplied 6 times. Okay, okay, so it is something like this: 1 0 0 0 0 6 times, 6 times zeros. Okay, so we have the 6 times zeros. Okay, so what we'll do now? We have this, so we will multiply it here. Okay, so I have that. So we have this. Now we need to change it. Okay, so into second above. Okay, so we need a second above. Okay, and 10 to the power 6 below. Yes. Okay, you have missed something. Okay, just go through my code once. Okay, that's why your coding is showing wrong. Okay, so you just missed a semicolon, or you just type a word wrong. Okay, that's the thing. Okay, so we just cancel this. Okay, so this is a second. Okay, so we just cancel the second to second, and we have the microsecond left. Okay, so for our new thing, here all the drawings. Okay, so we have this distance equals to. Okay, so we have this 3 4 4 0 0. Okay, 3 4 0 0 0. So we multiply it to 100 by 10 to the power 6. Okay, let's sort it out. So we have 10 to the power 3 to 10 to the power 6. Okay, we can write it as something like this: 34 into 10 to the power 3. Okay, and we have 10 to the power 6. Okay, and we divide this. Okay, so we get 10 to the power 3 left. Okay, so it is something 34 by 1000. Okay, so when you divide that, you get 0.034. Okay, so you got something like that. Okay, it's clear all the drawing. Okay, so we get a number. What is the number? Is 0.0. Okay, so we get a number which is 0.034. I'm sorry, 3. Okay, so we get this number 0.0. Okay, what is this? This is a centimeter upon microsecond. Okay, we'll get this number. Okay, so we have distance is equals to multiply by our time. What is our time here? Our time is this ping travels time. Okay, so we have this ping travels time. Okay, so we'll multiply our ping travel by time with this number, and we'll get to this. Okay, let's do that. Okay, you can note it down if you have to. Doesn't have noted down. Okay, so that is clear the drawing. Okay, so okay, so now we are here. Okay, we got our speed. Okay, so now we need a distance. Okay, so we call it distance. Okay, this time we need it in a float. Okay, so because we need it in a float, because float is a point variable. Yes. Good morning. Okay, so we need a float variable. What the float variable means? It means that it can hold a it can hold a distance. It can hold a value which is in decimal. Okay, so we use that float variable. So we have the float distance. Okay. Okay. So now we need to calculate the distance. Okay. Distance is, okay, so for the distance. Okay, so we follow the distance. Distance equals to speed into time. Okay, so what speed we got? We got 0.034. Okay, so we got 0.034 multiply by, okay, we multiply by ping, ping travels travels time. Okay, so distance in things travels times. Okay. And we are not printing this time our angles time, so we're printing distance. Here, so we're taking the distance and our my friend. Okay, hope everything works fine and we will start soon. Okay, let's see. Okay, so it is showing us 21. Okay, so let me make it a little bit stop. Let me make it a little bit change. So after that we have it. So let me paste it. Okay. And we will have this in the place of distance. We'll write a string. Okay. We'll say that centimeters. Centimeters. So I'm starting the code again. Okay, it's not showing something else. Okay, 1 second. Oh, sorry, my mistake. Okay, so this Alan is very specific. Okay, so you need to put it in the right place. Okay, so I'm changing the line. And okay, Alan means new line. Start here on. Okay. Okay, so it's showing us the exact distance. Okay, it's showing that 41,412. Okay, and showing us now when I change it, it's saying 27.3 centimeter. Okay, but it is 139.8 centimeter. Okay, so why this is having a mistake? Okay, so we are getting a distance which is double than the distance of here. Okay, so anyone can guess. Okay, so this mistake I have done purposely. Okay, so can anyone guess that what mistake we are doing here? Hello. You can type. Okay, so you can type. Okay, so we are doing a mathematical mistake. Okay, so what mistake we are doing here? So why we are getting a distance that is double times the present distance? Hello, I'm waiting for your answer. Guess it. Nice. Guess fast. Okay, so why we are getting a double distance? Okay, so if I'm placing an object. Okay, this is an object. It's an object which is at 93 centimeter. Okay, and it is showing that 182 centimeter. Why this is coming. Anyone? Hello. Okay, sir, you have wrote distance in centimeter. No, that's not. I have wrote the distance centimeter, and this is also in the centimeter. Okay, you can see that. Click it here. Okay. Okay, 1 second. Okay, so it also in the centimeter. Nice guess, but anyone else? Very good. Anyone else guess? Guys, guess it. Guess it. It is a very genuine and common mistake. Okay, so it is not about the programming. Okay, it's about the basic mathematics, the speed into time to distance formula. You are in the 8th standard, guys. You can figure out. Okay. Come on. See. Okay. Okay. I will give you a hint. We are getting a. Okay. So we are getting a distance which is just double of our actual distance. Come on. Come on. Come on. You can do that. Anyone? Hello. No one is there. Okay. I will tell you. Let's stop the simulation. Okay. Okay. So why it is coming double the distance? Okay, because this time. Okay, this time is okay. We can run this. Okay, so, but why this time is coming? It is time is coming from going the distance. Okay, so our sound wave is going there and coming back. Okay, so it is a distance. It is a time of it is a time of coming and going both together. Okay, and the distance is also together. Okay, so distance is the wave going from here and coming back to the sensor. Okay, so that double time the distance. If we just divide it by 2, we'll get our answer correct. Okay, so if we just divide it by 2, okay, so this is our. Okay, you can divide the speed by 2 or you can divide time by 2. I will just divide by time by 2 because sorry, divide by time and divide by 2. This way. Okay, let me run it again, and I hope. Okay, okay, so it's coming something like 94, 94 point. Okay, it's 97. So we are still somewhere. It is 96 centimeter, and we are getting 93 centimeter. So we are getting some error in the percentage. Okay, but it's quite good. Okay, so we are getting a 3 centimeter error. That is a very big error. Okay, let's nullify that error. Okay, so what we have did wrong in this. Okay, so I think we have not have the right specific what we call that. So accurate. So we write accurate. One second. So we have a message. My screen is not visible. No, I'm sharing my screen. No, I'm sharing my screen. Don't say anything which is no, irrelevant. Okay? I know that none of you guys are not curious, but it doesn't mean anything. Okay, okay. Let's change the import. Okay. So, actual speed of sound is something like 345 something around. So let's change a little bit. Okay, so we have this. Okay, and I'll just change this to 5. Okay, so actual speed of sound is around 344 something. Okay, so we are using 5 to make it a little bit more accurate. Okay, okay, so we'll start simulation. Okay, let's see it's 96. Okay, it's showing that 95.3 centimeter. Okay, so we are somewhere close to our. Okay, so you don't need that much precision. Okay, so this precision is very enough in the real world. Okay, so if you get an error of +5 and -5, that is okay with the sensors. Okay, so you're getting an exact result. Okay, from this dilemma. Okay, so you understand two things. Okay, first how we measure the sound. Okay, and the second thing that how we measure the distance with the use of that sound wave. Okay, and the third thing also that the third thing was that concept of this microsecond. Okay, so you can use that the microsecond. So what we do in previous time that we use only the delay, okay, and we give it in the microsecond, sorry, millisecond. Okay, but now we give it in the microsecond. Okay, okay, let me just zoom out this. Let's stop the simulation. Zoom out the whole thing. Okay, note it down fast. Okay. Till the time you note it down, I'm coming over. Okay. Then also. So in which line it is showing you, Rajesh? Please log in once again. Okay. So if you're not able to see that. Okay. Errors and I cannot find it. Okay. So tell me the errors. What's showing? What is telling? Okay. You will not have been hooked with them. Okay. So if it is not in the, if it is not coming in what we call that in software, then it is must be in hardware error. Okay. You have hooked the right pins. Okay. Check your pins and check the physical pins also. Okay. Well, using pin number 11 and 12. Okay. Send it. Send it. Send it. Okay. You can send it to the chat box. Okay. So you want to paste my code. Okay. 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 I have pasted my code. Okay. Check the. Okay. Check your parentheses. Okay. Sometimes parentheses also play an important role. Or that what we call that capital and small letters. Okay. Note it down each and every line. Okay. So those who are getting errors. Okay. Try to run this code. Exactly copy this and paste it. Okay. And remember the hardware also. Okay. Anyone else has doubt?